Good afternoon, everybody. What's up? It's Greg from GregsTutoringNYC here. Um, Continuing our series. I think this is part 6. I'm not actually sure. Yes, actually, I just got a notification from my mail. That's part 6. Peace in, y'all. What's up? What's up? Um, so we're continuing on with the so-called hardest math problems. These are from grade 8. And I'm just going to jump in here. We normally go about an hour. My voice gives out or whatever, I might go half an hour. If I'm feeling rejuvenated, I might go on an hour and a half. So we're going to do about a dozen questions probably. Takes 5 to 10 minutes for each question. If you're catching this on the replay, you can hit pause and see how I solve the problem. Either way, hopefully you guys enjoy this series. It's math, so it's not the most exciting thing in the world, but please like and subscribe. Set your notifications on. After I do maybe about 2 more of these, I'm going to start doing SHSAT material. Anybody who's taking that exam. And most of the problems are all applicable to all the exams anyway. Most of them have math and ELA. I'm probably going to do a cover-to-cover review of it. So just for a heads up for anybody, that's probably the next thing I'm going to do. Probably starting next week. I thought I would be able to get more of these hardest math problem series done quicker because I actually started this in the actually I don't know when I started. I think I started in the summer, going back into starting from grade 3. So let me just get this set up so I can see anybody posting messages. And let me just make sure that it is actually live. I would be able to get more of these. Yeah. So let's just jump into here. And let's just keep going until we conk out or not conk out. And if anybody needs to email me, please email me at GregsTutoringNYC@gmail.com. You can also post comments below and comments in the chat for anybody there. I don't do these consistent enough, so I might not get anybody on the stream. It's a day off for you guys, kind of in a way. It's election day, so I guess it was Halloween. So pop some candy in your mouth and sugar yourself up. And let's see how we can go with the flow here. All right, so I'm going to jump right in here. If anybody has questions about something I'm not talking about on the screen at the moment, pop them in the chat or pop them in the comments. And when I get to them, I will normally at the end. Or if I just feel like it's an applicable question, we'll jump into it. All right. All right, so the first question is 2 rectangles. So let me just look at the illustrations first. Let me make sure I got that right. Okay, so there seems to be a rectangle P with a width of h and a length of j plus 4, and another rectangle Q with a width of j plus 1 and a length of 3h. And the illustration is not really giving us any more details than that. And I'm going to guess they're going to compare the areas or perimeters or something, because that's what's normally happening here. And somehow we need to tie the 2 J and H's together from the applicable respectively between P and Q. There's really nothing else I can get out of this illustration. So I like to look at the illustration first and then go to the words. 2 rectangles are shown below, so that's good, because it's confirming stuff to us as we get to look at the question. For instance, this is also H then, and then this is also J plus 4. Since now that we know that it actually is a rectangle. Okay. What did it say? J plus 4. Okay, and then this here must be 3h. By the way, I'm stopped right here. I haven't finished reading the thing. I'm just trying to understand this, what they're giving me. So that's 3h, and this would be j plus 1. Okay. This is kind of too trivial, so I probably would not make these notations on the actual test. Although I kind of do draw these lines here, I would make a mental note like, okay, there's 2 rectangles, stop. Okay, then it says rectangle P has a perimeter of 20. So I'm just going to put equal 20 here, because that's the one it's applying to. My tablet software is not keeping up with me today. And then rectangle Q has a perimeter of 30. And I could say P equals or something here. P equals 20, meaning perimeter, not rectangle P, and P over here equals 30. So it looks like they're going to have us compare the two of these. So let me kind of scroll some of this off the screen so we can start looking at part of what they're asking us for the answer part. Let me just make sure that's showing on your guys' screen. Yes, it is. My voice is already giving out. That's not good. So that is, they're looking for the values of J and H. Now there's a couple ways we can approach this. There's kind of three ways. One is to just understand this conceptually. So what it's going to mean is if the perimeter of P was 20, it means we have H plus J plus 4. So we're going to just take each side one in turn. Okay, so basically we got this and this, and now we have to get the other two sides. So it's going to be plus H plus J plus 4 again. Okay, and they're telling us that that's equal to 20 because that's the sum of the lengths of all the sides, and that's by definition what the perimeter is. Okay, given the nature of this, there's also something else we can say, and I'll write it down here. In fact, let me change the color so that H plus J plus 4 is equal to 10. Right? If all the perimeter is 20, then this here plus this here must be half of that because it's half of the perimeter. It's the width plus the height plus the width plus the height. If that's 20, then the width plus the height is 10. So we kind of simplified that, right? We can do the same thing over here for this, which is that we can get 3H plus J plus 1 Now, since that was equal to 30, we know that the length and width must be equal to 15. Again, it's a rectangle, and that's the properties of what a rectangle would basically have. Okay? So given these two equations in green, we have two choices. We can do substitution. So we can first of all come back to the original H plus J plus 4 and subtract 4 from both sides. Right? And then we get 6. All right? So we can basically, let's try to solve for J. Right? So J equals 6 minus H. Okay? And since both of these rectangles are both using the same H and the same J, because that's what they're telling us. They're actually not telling us they're affiliated, but we can grasp that it's not a different H, it's the same H. We can plug that in here. Let me change the color again. So if J is 6 minus H, right, we can basically get rid of that J and put the 6 minus H into there. And then we end up with 3H plus 6 minus H plus 1 equals 15, right? Well, the 6 plus the 1 is going to be 7, so we're going to subtract 7 from both sides. So we can get rid of this, and that becomes 8. And then the 3h minus the h is just 2h. So we get 2h equals 8. And therefore, h is equal to 4. Okay, so if we look at the answer choices, we have two scenarios where h is 4, both B and C. So for that, we have to figure out what j is. So we can go back to either equation with the h equals 4 and plug it in, right? And including the original equations I had up here in the purple, the h plus j plus 4 plus the h plus j plus 4. But if we just work with this, that we're telling us that the h is 4, so we have 4, right, plus the j plus the 4 equals the 10, because we subtracted the 4 over the both sides. Actually, let me write that out again in the red. So we have h plus j. And we can use any of these. We don't have to start from the original one I started with. H plus j plus 4 equals 10. So if h is 4, that was a 10. So we have this 4 plus this 4 is 8. If we subtract that, we get 2. And we could get j equals 2, which is over here. That gives us choice number C. Okay, so now what we have to do is plug that into the Q thing to see if that's really the 15. So 3 times h, right, if h was 4 is 12, right, and j plus 1 would be 3. So 12 plus 3 is 15, and that was our original equation. So that actually checks out. So now it turns out there's a whole second way to solve this, which is if we use simultaneous equations. So we had the 3h, we had this in green here. The 3h plus j plus 1. So that's the same as 3h plus j okay, and I'm going to take that original 1 from the green and subtract it off. So that's equal to 14. Okay, and if we start from this as well over here, the h plus j, so we have h plus j, okay, and we took the 4 from that, we got 6. So if we subtract these two equations, 3h minus h is 2h, j minus j just cancels out, and 14 minus 6 equals 8. And h is 4 again. And once we get that, we can plug it in. We could have also arranged it so that we got rid of the h's as well. The way to do that would have been to change the second equation, because we solved for h in the red here. I'm going to change the color, and if we multiplied the whole second equation by 3, we would have gotten 3h plus 3j equals 6 times 3 is 18. Okay, and then I actually would have inverted the order of these two. Yes, I should. I'm a good Samaritan. I'm a good citizen. If we subtracted those off, uh, we would be solving for the j in this case, right? and we would have gotten 2j equals 4, I believe. Yeah, 2j equals 4, and then j equals 2, and that would still give us c. So we can use these alternates. This can be a very involved problem. You know, the other way to solve this, there was another way, which is to just plug in each answer. In some ways, that may have actually been faster than both of these, but I'm explaining this, so actually solving it using either the substitution or the simultaneous equations probably is just as fast and just as quick. Thank you, KS. Yes, I'm good to you guys. Give me thumbs up, like and subscribe. Pass the word. Like, share, subscribe. Yeah, smash that like button. All right. So that's the answer to that one. The next question is pretty busy. Give me 1 second. I just dropped something. Okay, so I normally like to look at the illustration first, but there's a few illustrations and they're all the answer choices. So what I'm going to do is just look at choice number A to just get a perspective of even what's there, because in this case, all the answer choices look similar, except for the numbers written in. So it says number of t-shirts sold. There's color, small, medium, large, and there's between blue and green. So for choice A, it implies there were 60 blue t-shirts and 58 green large t-shirts, right? And so on and so on. So depending, what did I say, 58? It's 60. So remember, guys, I have dyslexia, so numbers can swap on me. Doesn't happen too much with words. I got the 58, I'm pulling it from there. But I actually looked at this and saw 58. All right, let's ignore that for a second. So, all right, so, and then choice number B has a different distribution. So I notice in choice A, it's the same this way, and this way. And there seems to be just different patterns going on in each choice. I'm going to assume they all add up to the same number in some manner, but let's go to the words and see if we can get anything meaningful out of that. Okay, let me just center this for you guys so you can actually see the sentence. Yes, they are state test questions. These are questions that most kids got wrong. Um, so that's why we're doing them. And then not always for math reasons that kids got them wrong. So these I chose because first of all, if you've taken the New York State test or any state test anywhere, these are kind of representational examples of grade level. The other is that these remember these tests were taken by hundreds of thousands of kids. So if only 20% got them right, that means 80% got them wrong. So that's 80% of 200,000 kids. There's a lot of kids who got a question wrong. All right. So we're trying to go over it that way. So these are not necessarily mathematically hard, although some are, but some are kind of just their gotcha ones. That it was attention to reading, misunderstanding a table, whatever the case may be. These are just historically the worst questions for most students taking the New York State test. And that's that some of these are applicable to the ISEE, the SSAT, the SHSAT, the TACHS, which is next weekend, the Bergen County Academy test, the Hunter College High School test, this, the PSAT, even the SAT. These all become applicable because it's the same level of mastery of math and attention you need to do. Now, I'm not saying these are as hard as SAT questions, but if you're training yourself in that kind of test-taking mode and working with questions and thinking through and pumping up your numeracy and things like that, it kind of makes sense. So these are useful for basically anything. They're just supposed to represent grade level. And of course, the premise is that if you do have a harder exam than this, if you're struggling with these questions, you will definitely struggle on all the exams I just mentioned. So in a way, this is prerequisite and requisite material. So you need to master this kind of stuff before you can bump up to the next thing. Because what happens is I work with a lot of kids for decades now, and they start getting sidetracked because, let's say they have an SAT problem to solve. There's, first of all, the novel approach they take for some of those questions. Then there's the little twist on it, and then oh, by the way, there's the math knowledge, and that's kind of a whole bunch of levels deep into it. And if a kid doesn't know the math knowledge part, the rest doesn't really matter, and it's not helpful to them. So we're trying to give foundational kind of material in these sessions. That so not only can it be useful if you're an eighth grader, and I've done this from grade 3, 4, 5, 6, 7, 8, but it's the foundation for building up on any other kind of problems you're going to solve, especially at grade level. Okay. Whoops. Okay. So the words: a school club had a T-shirt sale to raise money. Cool. So this is apparently the number of teachers sold, and that's what it says. After the sale, an inventory showed 108 blue shirts, 96 green had been sold. Um, so if we add it across, we're going to get 108. Right? And as I solve problems, this is the way to do it. And if we add across the 60, 86, and the 58, um, where are we? 96, okay, have been sold. So I'm assuming it's gonna, yeah, and that's what's asking us. The sizes are 60 small, 86 medium, and 58 large. Which table would represent that? Well, if we add this and this and this, um, we can't get 108 the same if we go across that way. So the answer is not A. Blue, we're going to get 30 plus 40, 70, plus that is 90. 6 plus 4 is 10, 100. So that's 108 for sure. And the green is 30 plus 40 is 70, plus 26 is 96. So B looks like the answer. And then you guys could just add up the other ones just to see what's going on there. So I'm going to guess they put sum totals. If you added going this way, that would add up to something interesting. Okay, but that's not what they're asking. So be careful as you're reading these problems, what exactly they're asking you to do. All right, because there's probably something that added up to 108 in a different direction or something. So this is just really testing how you're viewing tables and so on correctly, and understanding the data as it's being presented to you guys. All right. I don't think so. Who's that? Why does that matter? Okay, so the next question um, is getting back to coordinate geometry. So we have we have what appears to be a triangle going through a whole bunch of different sectors on a coordinate grid. I always check I'm X and Y. Okay, I'm 1, 2, 3, 4, 5 in each direction, including minus. And we have F prime, H prime, G prime. That's the name of apparently a triangle. With certain coordinates, we can certainly pick out like F prime seems to be minus 1, 2. G prime seems to be minus 1, 1 comma minus 1, and so on. All right. And then there's really nothing more to get out of the illustration. And we can actually go back up now to the words. The vertices of a triangle are located at F, which is here, minus 4. So this the one drawn is the prime one. So there's going to be another one which is minus 4, minus 2. So that would be F. I'm not sure which way this is going to go, so I'm going to put the F here, but I may have to cross it out. The triangle goes that direction. G, which is going to be 2, 2. So that's G there. And then H is going to be 0, comma, minus 4. All right, so I'm just going to draw this as best I can. So need to kind of do is perceive kind of what's happening here. This appears, so let me just read the rest of it because I might make statements that don't apply to the sentence. So a sequence of transformations to triangle FGH results in this. So a transformation is either shrinking or expanding a shape or twisting it around or moving it around, okay? So we can rotate it and so on. So something happened to FGH to twist it and rotate it and shrink it to be F prime, H prime, G prime, okay? So that's basically what's going on there. So let's scroll that off so we can start to kind of see the answers. Let me bring this enough to at least get ABC into play there. Can we fit D? We may not be able to. So if anything, you can see that going from the green to the black is going to be a shrinkage. So if we go back to the question, we're going from the non-prime ones, wait, let me get that on the screen, to the prime ones. Okay, it has to be in that direction, not the reverse. We're going from the green to the black, not the black to the green. So there's a shrinkage there, right? Okay. So let's see if we can get that. So a dilation of a scale factor of 2 means we're increasing. So that's not A because we shrunk the thing. Okay. B also says a dilation of a scale factor of 2. So it's not that as well. C says a dilation of a scale factor of 1/2. So that seems about right. Okay, and what about D? D is also a dilation of a scale factor of 1/2. So we have two things. There's going to be this part, I'll underline it in purple, and then the green. So now the question is, did we shrunk the triangle and it was rotated? It was either rotated clockwise or counterclockwise. Clockwise is going to be the way your hands of a clock go, which is that way. And counterclockwise is going to be the opposite way, that way. So we need to, I'll bring the image back down. And remember, we're going from the green to the black. And each way is talking about 90 degrees, okay? So for some of you, this can be hard to visualize. So for most of you on test day, you can have an actual piece of paper that you can kind of rotate. That's kind of a hint for some of these geometry problems. So can I take this triangle, first of all, I'm shrinking it. Am I going to move, say, this point and rotate it around that way and the purple way? Will that give us the black? Or am I going to kind of take it and rotate it that way? Okay, whoops, I thought I changed the color, but, oh, I did. Whoa, that was weird. I don't know if you guys saw that. So which way brings us from the green to the black? It's going 90 degrees that way. All right. So it's clockwise. So it would be D. D is the answer. Okay, so two transformations happened. One was a rotation and one was a dilation. Okay. So sometimes it's hard to see that. And if you actually printed this page out, and if anybody wants to email me, I could send you the PDF page or a JPEG of it. You can actually rotate it, or you can copy it with when it's straight lines and trace it on top of it. And if you do that rotation of just 90 degrees, you'll see it ends up like that. There's no point drawing it because that's actually what F prime, H prime, G prime is. Okay, and I know I'm saying that the name's slightly different than the way they wrote it. So unless we're caring about that G needs to be in the center, we can call it FGH, GHF, or HFG. And there's actually probably other choices there as well. All right, so it's that unless we need to like get this angle right in here, we don't care what we call that triangle as long as we know we're rotating the same triangle back and forth. All right, so that's what that one. Give me 1 second. I just want to make sure we're still live. Yes, we are. Okay, so this number 24, it kills you guys every single year. This is a killer kind of a question that just kills y'all. So first of all, there's what does exponents even mean? Okay, so that's if you're stuck on something like this, just start out by using what you know. Okay, so hopefully you know that a base to an exponent times the same base to another exponent, let's call it x, this is equal to the base come on, why is that not writing that? With the addition of the two exponents. Okay, so if we had, for instance, b squared, and if you can't memorize it, this is a way to kind of prove it to yourself by using simpler numbers. If we had b squared times b to the third, well, this is b times b. Right, and I'm going to just draw like an artificial line right here for a second. And this is b times b times b. Which, if b squared means there's two b's being multiplied and b third means there's three, we're ending up having 5 b's multiplied. So this is equal to b to the 5. Okay, so all we did was, if you just memorize that that's the formula, you're cool. Okay, the other thing we have is this set up like that. Okay, and if 2 to the 4th to the 3rd means we have 2 to the 4th times 2 to the 4th times 2 to the 4th. Now I could write out each of those, but if we just use the rule that we just had, we're going to get that's equal to 2 to the 12th. 4 plus 4 plus 4. Which actually gets to be a big number. 2 to the 12th actually goes pretty fast. And it's not asking us to do that, but just for context, 2 squared is 4. So 4 times 4 is 16. So each of these is 16. We basically get 16 times 16, and you should all know what that is, 256, times 16 again. So all of a sudden we get this enormous number, right? So, ouch, right? So, so what it's asking us to do now, if we, with all this in mind, if we actually look at what the problem is asking us, it says, what is the value of n? Like, huh? What? So it turns out that if we take this 2 to the n plus that, this is 2. And if we use the rule e plus x there, it's 2 to the 2 plus n. Okay. And we already said that this was 2 to the 12th. So what we're going to do is kind of do something that probably going to look weird to you originally. But, whoops, how do we get rid of that? all we're going to do is assign the exponents to each other. So we have 2 plus n equals 12. So this is a distinct difference from how you guys were told how to solve your algebraic equations. When you solve for x, you guys were never shown how to do it when the x was part of an exponent. Okay, so this is how you do it. Because the base is the same. Since the base is the same, then 2 plus n must be equal to 12, and therefore n is equal to 10, which is choice C. And if you plug it in, you'll see that 2 to the 12th equals 2 to the 12th. So it makes sense. So this actually turns out to be like a weird scenario for where the x is. In this case, it was n. But we just follow normal rules, and just keep that in the back of your mind when you hit a problem where the solving for the x, so to speak, in this case n, is just in a weird place. Try to figure out some identity where things would kind of sync up together and work out. Okay. All right, let me see how we're doing on time. We're 41 minutes, so okay, we'll do a few more. my voice is still holding up, so. All right, I see a few people in the chat now. Welcome, hello. Please like and subscribe. Please join in and try to answer the questions if you think you know the answer. I'd love for this to be interactive. All right, so we're going to look at the chart first. We have hot coffee sales. Okay, this seems to be a scatter plot there. If you don't know what that is, Google it and try to figure it out. It's basically all those dots you see there. There's something that's been recorded, and normally with the scatter plot, you're going to try to figure out what's called the line of best fit among the data, and it basically would kind of go through the middle, something like that. And I did that real sloppy, so let me try that once more time in a different color instead of bottom to erase it. The green is probably a cleaner line of best fit, and then in some cases, like this and this, might be considered outlier data. It's kind of like if you look at anything like take wealth, there's the top 1% is more wealthy. That's their outlier. That's not the average salary. If the average salary is like 50 or 60,000, somebody making $1 million is just kind of out there. So if this was actually salaries, the $1 million would be all the way over here. So it doesn't mean some of these are not outliers for whatever this is. So if this is like the number of coffees you drink a day, the average person doesn't drink 100 cups of coffee. So somebody who does or does, that's not following the average thing here. All right. All right. So the bottom, the x-axis, right, is by tens. Okay, and it's the temperature in Fahrenheit. And the y-axis is the amount sold in fluid ounces, and it's going by hundreds. Okay, so that might come into play if we need to play around with stuff like this. Since it's a scatter plot, they normally don't ask for exact coordinates here, so that somewhat makes it easier and harder at the same time. So the owner of a coffee shop compared the amount of hot coffee per day in fluid ounces. He sold. What does it say? I can't see. It's off my screen. The amount of hot coffee per day sold and the daily high temperature in degrees Fahrenheit per day. Her data are shown in the scatter plot below. So if we just look at that and try to understand it without question, if you notice, as the temperature increases as we go from 10 to 90, my fake line there goes down because it means that as the temperature increased, people drank less coffee. Or we can look at it backwards as the temperature increased, like if it was 10 degrees, that's pretty cold, people were drinking more coffee because that number is going to, or at least they sold more, with the implication, the inference that people were drinking more. All right. So, and I guess that's true of stuff like, you know, you might have somebody drinking hot chocolate mostly in the winter and not necessarily in the summer, even though it tastes the same. Um, you know, keeping their hands warm, just kind of things like that. All right. So we don't know what the question is yet. So let's take a peek. So let me bring this so we can start seeing some of the question. Let me shift that a little more so maybe we can get B stuck in there as well. I don't like shrinking it down because then I have to shrink it back up because some of you guys then tell me you can't see it. So we'll just take things a piece at a time, especially when we're looking at the answer choices. All right. Um, if the data are modeled by this line here, so they're telling us that there is an equation of a line right here. Which statement best describes that? So my green line is supposed to match that. In fact, let me get rid of the red line just to make this, yeah, there we go, make a little more sense. And if we follow this as y equals mx plus b, well, first of all, a positive slope goes this way, right? And a negative slope goes that way. So since this is minus, my line is going that way. It's telling us that b, the y-intercept, is 850. So that's going to be right there. So my line was kind of cool, at least from that point. It's at 850, and it's going to go down, right? Rise over the run at basically 6 over 1. Or we can have 600 versus 100 or something like that. It kind of really doesn't matter. So if the data is modeled by that, what statement best describes a valid predictor the owner could make? So it's going to ask us something about that line, maybe about the scatter plot points as well, because they're around it. So for each temperature increase of 10 degrees, so as we go along here for 10 degrees, the shop can expect to sell about 60 fluid ounces more of hot coffee. Well, as I said earlier, they're selling less hot coffee, right? As we go along here, the number of fluid ounces is going down, right? We're going down a path, so it's not A. B, for each temperature decrease of 10 degrees, so now we're going to go back the other way. For each decrease of 10 degrees going that way, right? The shop can expect to sell about 6 fluid ounces more coffee. No, I don't see that, right? Because this is in hundreds. Okay. Plus, if we actually plug in the x, this is the x. So it's actually times 10. So it actually should be 60, about 60. Okay. Our x in this case is the temperature. So if it's going down 10 and the slope is minus 5.9, we're going to have 5.9 times 10, or 590, or about 600. I mean, about 59, or about 60. So it's not B. On a day when the temperature is 0, so we're looking at something right here. If the temperature is 0, the shop can expect to sell about 145 fluid ounces. So that's about right here. Well, the line's all the way over there. There's not even an outlier point here. So C doesn't seem to be it either. So D better be it. So it says on a day with a temperature of 0 degrees, the shop can expect to sell about 850 fluid ounces. Well, that was the y-intercept. So that makes perfect sense. It fits the formula. And if we come here, over here, right? So when it's 0 degrees out, they will sell 850. So that's exactly what it is. So the answer in that case would be D. D is in dog. All right? Okay, so we have another one here. Just based on the way it's looking, I'm guessing this might be a transformation or an area question. So we have coordinate geometry. Everything's by units of 1, 1, 2, 3, 4, 5. There's 2 squares. I know they're squares because each is 2 by 2 in the coordinate geometry grid. So PQRS is a 2 by 2, which is area 4. I don't know if they're going to ask that. They may ask us to get like the volume if we were to connect these up and make a rectangular prism out of it. They may ask us to do that. I don't know. So let me remove that because I don't know that's where they're going here. And then WVUT is also a 2 by 2. So I don't know where they're going with some of this. But we can identify certain things. So it says, if we go down to the question, square PQRS and TUV are shown below. So we can kind of scroll that off. And again, these are X and Y geometries. What sequence of transformations? So my guess was right. I guess it was either between area and volume or moving stuff back and forth. Of square PQRS. So we're going from square number A, square A to square B. Okay. You always have to make sure when you do these, you're going to go in the direction they're asking you for. So the transformation in this case is going to be from A, and I don't know why I just said this, but in this case, we're going to go from A to B, not from B to A. Okay, follow the English, right? So we're trying to show that there's a congruency. First of all, we see it's a 2 by 2, but they're asking us, how did A get to B? Okay, so a translation 2 units up and 2 units to the right, and then a reflection over the x-axis. Okay, so they're saying what transformation of this square, right? How can we move square A, which is PQRS, so that when we do the transformation described in the choice, it gives us square B, okay? So if I take A and move it up and to the right, it's by 2 units. I'm going to move it up 2 units. It's going to be over here, okay? So that's not A. B says 2 units up and 2 units right. So again, it's not B. All right, we should be able to fit this here. Yes, we can. C says 2 units down and 2 to the left. So if I bring A down 2 units, if I bring it down 1 unit, it's here, right? And if I bring A down 2 units, it's here, okay? And if I bring it 2 units to the left, it's going to be here, where the purple is, okay? So now both C and D both say 2 units down to the left, and then there's a reflection over the x-axis or a reflection over the y-axis. A reflection basically means if we put a mirror. So if we were to put a mirror on y, then the square is going to come over here, okay? Because we're reflecting it over this axis, okay? In our case, we're going to reflect it over the x. So we want to have something symmetrical to that. Oops, 1 second, this is syncing. Syncing for too long. Okay, there we go. So we're going to basically flip it as if you put a mirror up to it. What would it look like on the other side? Okay, so we're going to do it over the x-axis, right? The y-axis is going to give us something else. So our answer would be C in this case. Whoops, that's the end of that question. Go to the beginning of this. So again, I'm Greg from GregsTutoringNYC at gmail.com. Please take this time to like and subscribe, share, comment, poke in the chat. All right, so we're going to do about 1 or 2 more questions. If I can get back to the beginning of where I need to go here. Come on. This is going on forever. I do tutoring as well, guys. So anybody who needs tutoring, please feel free to email me at GregsTutoringNYC at gmail.com. What's going on? Why are there so many problems here? All right, I think we have 1 more page to go through. Nope. Come back. All right, there was a delay, which is what happened to me. All right, let me try to get this back. Let me just make sure I didn't skip anything, because that's something I think we did the last time. No, that's the one I wanted. Okay. All right, give me 1 second, make sure we're on the right page here, because I don't want to skip. I think they're in rows of 10, so. Okay, yeah, that we did. So we'll drag this up. All right, let's see what time we get at the end of this page. Because there's actually still about 30 more problems in this whole section, I think. I'm just looking now. It'd be great to end this series finally. Okay, so there's 2 boxes here, box J and F. I have 3 feet by 4.5 feet by 2, 3 feet. That seems to be a rectangular prism. The next box F seems to be a cube, which is 3, 3, 3. Yep, the numbers jive, so this must be a cube. There's really nothing else going here. There's 2 types of shipping boxes, and now I have hiccups. What is the difference in the surface areas? Okay, so area is length times width, volume is the length times the width times the height, and surface area is basically if you were to put wrapping paper over these 2 things. Okay, so there's a couple of ways to do this. We can unravel it. Basically, what we're going to have is something. Let's just take the cube, where if we were to open it up. So this is flapping down each of the sides, right? And one of these, because that's the bottom and the sides, this needs to be the top. So in the case of the cube, there's 1 more of them, right? So in the case of the cube, each of these is a 3 by 3. So we have 9. So we have 1, 2, 3, 4, 5, 6. We have 9 times 4 is 56. I just said that backwards. So the area of each of these here is 9. Okay, there's 1, 2, 3, 4, 5, 6. So 9 times 6 is 54. Okay, so that would be the surface area of box F. Okay, box J is a little more annoying. So we would still unravel it in the same way. So for J, we have 4.5 would be one of the lengths here. Okay, and the height, let's see here, would be 2. And the length here would be 3, if I did that right. Yeah, you know what? Let me redraw the figures so that we can get a better viewpoint of what we're actually doing here. So this was 4.5. So let's say we're taking it from the bottom. So it's the bottom thing right here, this here. That's going to be 3. Okay, and then if we would unfold the front and the back, this would be 2, and then this is the back. That would be 2 as well. Okay, now we have to work on the sides. So as we said, this was 3, and the little height there is 2. And then this is 2 as well. So we need another one over here. And then what we have to do is add all those up. So if we were to label these A, B, C, and D, and then E, and I'm not going to necessarily show the top because my thing is already too sloppy, but we would have an F as well. So A and B are 3 times 2 is 6, so we get 12, right? A and B are both 3 by 2, so they're each 6, and there's 2 of them, so that would be 12. C and D are 4.5 times 2, which is 9 times 2 is 18. And E and F are 4.5 times 3, which is 12, is 13.5. And 13.5 times 2 is 27, I believe, right? So somebody spot me on this, because I may have done some of this wrong. So this plus this is 10, 20, 30. We get 57. So the sum of these is 57. And it wants to know the difference. That means subtraction. So 57 minus 54 is 3. Okay, that's the answer to that. So this is another exponent one that kills a lot of students, just slays them. So any number x is equal to itself to the power of 1. Okay, so in any number x is also equal to itself over 1. So these both come into play because what we have is we're going to map this into 2 squared over 1 times 2 to the 1, right? We use this rule to do that, and we're going to use this rule to do this, over 2 to the 4th. So our numerator gives us 2 squared times 2 to the 1. That's the same rule before, or you could just see from the original thing, that's just an extra 2. So we get 2 to the 3rd over 2 to the 4th. Okay, and if you remember what we did before, we had base to the e. That's a messed up e. Oh man, what's happening? Let's get rid of that. Times base to the f. Was equal to base to the e plus f. E plus f is the whole exponent. So again, you either memorize that or you figure out a way to compute it. Okay, well, there's also a semi-analogous rule to division, which is that b to the e divided by b to the f. Is equal to b to the e minus f to the power of e minus f. So this all means that we're going to get 2 to the 3 minus 4, and that's equal to 2 to the minus 1, which is choice number B over here. Okay? And if you think about it, this here is equal to 2 times 2 times 2 over 2 times 2 times 2 times 2. And that's, this 2 cancels with that 2, this 2 cancels with that 2, this 2 cancels with that 2, and we're left with 1 over 2. And by definition, this is equal to 2 to the minus 1. Right? Remember, this 2 down here is really just 2 to the 1. So 1 over 2 to the 1 is equal to 2 to the minus 1. Any exponent in a denominator, we can bring up to a numerator, and it's a numerator because this is basically over 1, right? Again, any number is itself over 1, we can get that. So that's a rule you must know for your exponent identities, how to map back and forth. There's another way to solve this. Let me change the color of this, which is that if we have 2 squared times, so that's this one, times this next 2 here, that's 2 to the 1. And the 2 to the 4 was at the bottom here. So if we just use the rule I just talked about down here, this is then times 2 to the minus 4. So we can get that base out of the denominator by negating the exponent. And like before, EF, if we add a third b here, like if we have b to the x times BE, then this is e plus f plus x. Okay, so in our example, we have 2 plus 3 plus minus 4. So we get 3 minus 4, and we get 2 to the minus 1. We still get b that same way. All right, so it still works out. Yay! All right, let's see how we're doing on time. All right, so we're an hour and 10 minutes. And let me just take a quick peek at the next example, because if it's super simple, I will do it. Nah, it's already involved. So hopefully you all enjoyed this. All right, please smash the like button. Let's do it. Let's do it. Let's do it. Smash it. Okay. Hope you all have a good day, and peace out. Hit me up an email if you guys have any further questions. Have a nice day, everybody. And now we go through the thing where YouTube won't let me log off. All right, I think it is now. Bye. Nope, not yet. Come on, come on.